Welcome to my Substack podcast, and there's an article associated with this. I just thought I would mention that to anyone who is listening via the usual Talkcast feed, especially for this one, because if I start to make any claims that seem to sound outrageous, there will be links in the original article, which can be found on Substack, which can be found via the link wherever you've downloaded this particular episode. There are lots of factual claims I'm making in this, and I'm not just pulling them out of the ether. They come from somewhere. So I'm referring to something. But rather than saying, this is coming from a Nature article, or this is coming from this website or that website, I'm not going to say that at all during this particular audio version of the podcast or of the article. Instead, just go to the article and you will see there that there are lots and lots of links where I'm referring to bits of research or particular pieces of statistical data that happen to be out there. With that preface out of the way, let me begin. The next episode of my readings from and reflections upon Chiara Marletto's The Science of Can and Can't, which is Chapter 6, Work and Heat, is well on the way, hopefully here tomorrow or the next day. Work and heat are the two primary forms of fundamental energy, so it has been on my mind of late. Hence this particular Substack article today, which I'm calling Energy. I'm going to leave remarks about the physics of thermodynamics, given Chiara's work in constructor theory, to the next episode of Talkcast itself, therefore. But for today, I wanted to try to bridge the gap between those timeless concerns about energy, the fundamentals of work and heat, and the more timely, contemporary and pressing concerns that occupy us at this point in history. How energy is used right now to power civilization and therefore problem solving and knowledge production. We want the lights to be on. We want the indoors of our homes and offices to be not too warm, not too cool. So we need adequate technology for air conditioning, and we want our computers and factories to help realize our creative aspirations. But all of this takes energy because so much requires electricity, and that electricity production comes with side effects. As we like to say here in the tradition of Popper, the solution of one set of problems, heating or cooling, energy for cooking or computing, leads to a whole other set of problems, waste and pollution. And those new problems are actually better than the original problems. After all, people were starving or freezing to death or being unable to use computers at all until those problems were solved. And now we've got some waste and pollution to deal with. This waste and pollution is a necessary byproduct because of the physical laws governing these processes. There simply must be waste. Nothing is perfectly efficient. And some of that pollution, in our case, happens to be in the form of a particular chemical, carbon dioxide. And that has been explained that when it's in the atmosphere, it captures infrared radiation as it leaves the surface of the planet and redirects it back towards the surface of our planet, of the Earth. And that process is known as the greenhouse effect. And this greenhouse effect gradually warms the planet, raising its overall temperature, especially when it's the enhanced greenhouse effect. With or without people, this is known to happen because, well, volcanoes produce carbon dioxide. But with people burning fossil fuels, this leads to, as I say, the enhanced greenhouse effect, which has been explained to cause various runaway processes like the melting of ice caps and even the melting of solid methane deposits on ocean floors, which themselves could accelerate the entire process of heating even more. For more on that, look up the so-called clathrate gun hypothesis. So given these changes that are happening and are predicted to continue to happen without our intervention, people have proposed policies to transition away from fossil fuels, the very things that, when you burn them, cause the increase in carbon dioxide in the atmosphere, which causes the enhanced greenhouse effect. And this has all begun to happen, this transition away from fossil fuels, in some places much faster than others. But in lockstep with this transition to non-fossil fuel burning energy sources, or renewables as they're called, there exists an argument that says the movement to renewable energy is happening too fast. The argument is that reducing to the point of eliminating our society's dependence on fossil fuels is happening at such a rate the amount of so-called baseload energy available in the electricity networks around the world will soon become, if it is not already, too limited to actually keep the lights on. Now, if that sounds like science fiction, it isn't, because it's been happening in Australia just recently. Now, I've linked to an article that speaks about the transition from wood to coal, and then from coal to oil, and it explains how that took many decades in each case. And I might add, it didn't require top-down coercion in almost any case. People simply moved. They chose to go from wood to coal because it was clearly a better, cheaper, and healthier alternative. Better in almost every conceivable way. No one needed much persuading. It was better by their own lights. This is not so today. People do need persuading. There needs to be huge marketing or education campaigns. And it seems that only conservative politicians and perhaps spokespeople or lobbyists for energy companies, or complete outliers like Bjorn Lomborg, who's an environmentalist skeptical of the present solutions for global warming, or Alex Epstein, a philosopher who was a proponent of fossil fuels. It's only these kinds of people who argue that this transition is happening too fast. Some seem to be arguing it need not happen at all. So, there are the opponents of that whole seemingly pessimistic view that the transition is happening too fast. And the opponents are proponents of renewables like wind and solar, and green storage options like batteries, and perhaps pumped storage, which is the building of dams which can be used as sources of hydroelectricity during times of need. These are all coming online already, so it's happening apace. Technology invariably improves, and if we aim for a target of reducing carbon emissions and decommissioning coal-fired power stations and all other fossil fuel usage for the production of electricity, by the time this is all accomplished, the technology will be there to power a completely green energy grid, or as near completely as you could hope for. We can aim for the decommissioning of all coal-fired power stations by 2030, because by then we will have the technology available to take up the shortfall. By these arguments, Australia, for example, should be able to keep 95% of the coal it has available to it in the ground and never used. It is the only hope of stopping the warming of the planet beyond the crucial limit of 1.5 degrees Celsius, we are sometimes told. There's been modelling done by a group who published in the journal Nature, which said that although Australia needs to move to renewables entirely by 2030, other countries should aim for 2050, by which time 90% of the coal in the ground in the world will remain forever untouched after this, because it will never need to be. Now, that argument seems optimistic to some. One might even say it is blindly optimistic, because although it says the problem of how to replace carbon dioxide producing atmosphere heat retaining climate energy changing sources is soluble, it does not say, well, here is the solution now, but rather the solution is coming. Have faith in progress and technology. All we need is a policy change, and then solar panels put on rooftops everywhere will do the job that coal presently does when it comes to electricity generation, and just add some batteries into the grid for when the sun is not shining. What this argument may ignore is a couple of things. The first is that it assumes no other problems requiring an increase in electricity production suddenly will arise over the next few years as we do decommission the baseload fossil fuel power stations. It assumes a rather constant amount of use, and that use can be met by gradual replacement of coal with, say, wind, solar and batteries. So we must assume that, for whatever reason, the resources required to manufacture those things remain unaffected by global conflicts, extended bad weather, like weeks of cloudy, cold and windless weather in winter where the sun is already low on the horizon in many places, or supply chain issues, or the discovery of some hitherto unknown problems that a yet-to-be environmental movement will decide and campaign on as just being as damaging as coal after all. This is quite possible. Already some noises are being made about the chemicals in batteries and in solar panels. So there is that. The solution requires minimal disruption, which requires a certain degree of prophecy, presuming we can know what the future holds. This solution, this transition to renewables almost entirely, also assumes that the problems that are said to be with the burning of coal really do require a reasonably rapid transition to so-called renewable energy sources, and that this transition will lead to better, preferable problems than the problems created by the burning of fossil fuels. So, for example, the cost of renewables will easily be met by not only the people of poorer nations, but also the least wealthy people in the most wealthy nations, and that all of this can be done at a level of decision-making that is perhaps supranational and beyond the capacity of local governance to effect. The curious thing about all this is that historically every other transition that has happened, whether in energy from wood to coal, coal to oil, as already mentioned, or technologies from horse and buggy to automobile, or perhaps today to electric car, or from candle to incandescent light bulb to LEDs as we have today, or from transistor radios to black and white televisions to colour cathode ray tubes to plasma screens to 1080 flat screen LCDs to 4K backlit LED LCDs, or from transnational ocean liner to Airbus 380 transcontinental flight, and so on and on and on it goes. For all those, individuals, by their own lights, chose the preferred option because it was better for them, indeed objectively better, because it was cheaper and their standard of living went up. They could see with their own eyes in real time that their own bank accounts were healthier, and the smiles on the faces of their children, that each of those things was an objective improvement, and no government had to mandate a policy from black and white television screens to 4K LCD flat screens. But with the transition from coal to solar, it's not like this. There was a time, I remember, it was only less than a decade ago, when on my own electricity bill, it was actually made explicit there was a box one could tick to buy the renewable option. And for a premium, for paying more, you could choose to invest in, which is to say purchase, the electricity coming from renewable sources. Or you could buy the cheaper coal option. Then that option disappeared. But it's clearly possible for companies to do this at the retail level, to bundle up all those who tick the box for solar and renewables, and then purchase electricity from the wholesaler or provider based on what the consumer wants. Why is that not an option now? As time goes on, if solar really is cheaper because more and more solar panels are manufactured, then the price would presumably come down and more people would presumably choose to sign up for it. Of course, if that's not happening, but some authority demands it does, easy. They just take away the option. Move entirely to renewables anyway, regardless of what people want, regardless of what those people think about costs and efficacy, regardless of whether they understand that the transition is inevitable and is best for everyone on the planet. Technology improves and will continue to improve. We can literally cover vast areas of, let's say, the centre of Australia where the skies are clear with solar panels and wind farms. Yes, there will be a cost of transmission. Yes, there will be some difficulty with maintenance. Yes, environmentalists of a different kind may be concerned about the vast areas being covered and transformed by these technologies, and this may slow things down, as it always does, but problems are soluble after all. And there is something else to be said for this optimistic idea that replacing coal, oil and gas and transitioning to renewables by a particular date, even if it is not yet known how renewable technology can exactly fill in the gaps today, all on the assumption that it will be known by then. By the time the last coal-fired power station shuts down, we will then have enough renewable energy in the grid. We will know how to make up the shortfall because there will be no shortfall then. There will be wind and solar and batteries enough, even in the winter months when people need to heat their homes, but the sun is not shining much and the wind is not blowing much. Now and again, and perhaps there has been little rain for a while, so the pump storage dams are running low. Never mind. By then, we will know we will have solutions. Be optimistic. That other thing to be said for all this hope and optimism is, it works precisely in the other direction. If the argument is we do not have the technology right now, today, to transition to an entirely or almost entirely renewable electricity grid in a way we know will be reliable even in winter months when the electricity use is at its highest, but energy production from renewables is at its lowest, but we know in theory how it could be done, or at least we know that it could be done. We know about scaling solar and wind and batteries. Those technologies really do exist today, and it is merely a manufacturing problem, a problem enormous scaling of taking what some nations apparently already do on a large scale, and in the limit, having all nations do this to the same extent so that 90% or 95% or 100% of their energy comes from solar and wind, this argument that it can be done, it is just a matter of doing it, applies equally to removing carbon dioxide from the atmosphere and generating all electricity using fusion power as well. Indeed, it could very well apply to the argument that using the existing fossil fuel technology to power the technology that sequesters carbon dioxide directly out of the atmosphere. It is clear in some places now that the so-called transition to a green economy is not pain-free. Some think this pain is just a part of the process, and it's a virtue. If it hurts, it must be good. People may see their energy bills increase, but that's just part of the process. People may see blackouts or be told there is a risk of blackouts. That's a part of the process. There may be social division where to be vocally pro-green is virtuous, but to question it is to be reckless and uncaring. Part of the process. There may be fear where children are in tears, concerned about a planet that is endangered, where their own lives are endangered. But that's part of the process of persuasion. Why do people need to be persuaded of an emergency that we are told is already upon us and has been here for decades? It may be that carbon sequestration is possible, and not merely possible, but we already know exactly how to do it. But saying it is too slow is also part of the process. Being optimistic about renewables is the one form of optimism that is permitted. On every other technology like the promise of fusion power or the promise of carbon sequestration, we must be pessimistic. That is part of the process of transitioning to an entirely green economy. It's almost as if there are competing financial interests at play, motivating reasoning in one direction more than another. If the argument is that technology will save the day tomorrow when it comes to climate change, and this is why beginning the transition now by decommissioning coal-fired power stations today, then why does that same argument not apply with respect to any other solution to climate change? That technology will save the day tomorrow if we just keep using coal-fired power stations and any other cheap energy available, given that technology already exists that can remove carbon dioxide from the atmosphere, and or fusion power is known to be possible, which will make every debate over electricity generation hitherto that has been had for decades completely redundant, once it has been scaled to the level of every nation relying on fusion reactors for their baseload generation. We know that generating heat from fusion reactions is possible. The sun does it. Hydrogen bombs do it. In terms of controlling that reaction so that the heat production can be regulated in order to, for example, heat water to create steam which spins turbines connected to generators, it has been said it has been done in the lab efficiently in a kind of proof of concept kind of way. It seems that if anything in this space is inevitable, then this kind of fusion power is. Small, cheap, safe fusion power reactors which produce no waste, basically, except for maybe helium gas, which floats harmlessly off into the atmosphere. It might happen within 10 years, or 20, or 50, or maybe 100. But even without fusion, we've got fission. We already have a means of producing electricity at scale with next to zero carbon dioxide emissions, and which in theory could also be connected to carbon dioxide sequestering technology. And why no one takes the notion of planting trees, or even the notion that as concentration of carbon dioxide rises in the atmosphere, by whatever means, the amount of plants both aquatic and on the land rises in response too. It is not at all clear that as carbon dioxide concentration increases in the atmosphere, that in response, plants, especially marine plants, especially the phytoplankton, significantly increase their growth. That this happens across the board when it comes to plants. Increase the carbon dioxide in the atmosphere, the amount of plant life on Earth increases. This whole process is like a natural example of Le Chatelier's principle. For those who don't know the chemistry, Le Chatelier's principle is the idea of chemical equilibrium, where if you have a system that normally exists in some kind of equilibrium, then if the conditions change, such as the concentration of a reactant, then the entire system itself reacts to counteract that change. So here the idea is simple. Increase the carbon dioxide in the system, and in response, photosynthesis, which consumes carbon dioxide, is pushed more strongly in favour of the products, namely the production of oxygen and glucose, or in other words, plant growth, in order to counteract the change that is occurring. Now, whether and to what extent the plant growth increases enough or at a rate sufficient to counteract all the carbon dioxide being added to the atmosphere in response to the burning of fossil fuels, well, that's an open question. But it is the case plant growth has increased over the decades. For those who want radical change to the ways in which electricity is generated, this "the earth is becoming greener" fact is a very uncomfortable one, which is rarely mentioned, or mentioned only to be dismissed, or dismissed as a talking point of the climate change denialist. But aside from plants, it is also known that there exist ways of removing carbon dioxide, as I've mentioned, from the atmosphere directly. This so-called direct air capture, carbon sequestration technology exists today, but the problem is it's expensive. And why? Because electricity is expensive, and the relevant technology itself needs to be powered, hooked up to the grid. But in a world powered by, for example, fusion power, we could literally have entire fusion reactors devoted to nothing but capturing carbon dioxide directly from the atmosphere and placing it back into the ground, into rocks, which is kind of where it came from in the first place, as coal. And this possibility raises the interesting question. In such a world where electricity is so cheap because the only cost is the manufacture and maintenance of the power station itself, the raw material is literally hydrogen, taken from, well, let's say the electrolysis of water, how much carbon dioxide would or should we remove from the atmosphere? Would we lower it to 1800s levels if and when we could? Pre-industrial revolution? But why then? We are, after all, now in the 2020s, and by the time we have fusion power, maybe it'll be, say, 2070. And with or without people, the climate changes naturally. So should we project what the levels of carbon dioxide would have been in 2070, absent the existence of humans on the planet, and then adjust things to that level? But why would that necessarily be the ideal? What does ideal mean in a world without humans? And what if a volcano goes off, spewing vast quantities of carbon dioxide naturally into the atmosphere? Does the fact it's not a man-made climate change event mean we suck that carbon dioxide out of the atmosphere or not? Well, if we did that every time a volcano went off, that would upset the carbon cycle itself and rain patterns around the world. So would it be better to intervene so that deserts receive more rain or not? Should the tropics receive less rain in some places so that floods are a reduced risk? Or is flooding a part of the natural environment necessary for providing adaptive advantages for some organisms? What about forest fires? Do we use our carbon sequestration technology to neutralise the increased carbon dioxide in the atmosphere from forest fires? But haven't we already admitted, because we've learned that increased carbon dioxide is good for plants, that we should allow forest fires to continue? Is it only the man-made ones that we should worry about and not the ones caused by lightning strikes? If the argument in the first place with respect to climate change is that we humans caused it, namely it is anthropogenic climate change, and humans therefore by their very nature are unnatural, what they do is damaging, then how can a situation where we do more of that, of intervening, of controlling the environment by removing the carbon dioxide that is there and deciding how much there should be in the atmosphere, possibly be a solution to that, to the fact that our interventions are damaging? But then simply doing nothing is also not a solution, because we've already done so much, we are told, to the environment to change it. So should we change it back? But back to what? What is the pristine state of things? Is it where water and air is unfiltered? Clearly not. But should we let carbon dioxide from forest fires, volcanoes and underwater eruptions occur without our intervention because they are natural? Or should we just let all those things occur only in the places where there are no people? But what about the purported suffering of animal life there? Should we stop natural disasters where we can? Or is our intervention itself a priori a disaster? What about plants that benefit from the occasional fire and the entire ecosystem that, in the long run, benefits from big changes in the global environment, as has happened over geological time here on Earth? It is clear there are many, many more questions than answers here. What is unusual is that in a complex space of possibilities, there have been a few purported solutions that powerful businesses and political leaders have become fixated upon. Hitherto, only a small number of corporations and nations have found themselves fortunate enough to be in possession, in the right place at the right time, to have the natural resources literally beneath their feet to power the economy of the last few decades. Fossil fuels are not distributed evenly across the globe. They are, by simple luck, found only in some places on this planet and not others in abundance. They are an absolute boon to those who possess both the good fortune, namely those resources are near the surface, easy to get to, and knowledge, both political, scientific and technological, and will, the human will to scale these things up, use them and export them. Energy is a profitable business. But imagine you found alternatives. You found you could manufacture solar and wind and batteries and so on, but your great competitor are the old fossil fuels. So for now, it's just not economically feasible to scale all of those things up to the level of coal, oil, gas and nuclear-powered electricity generation. What are you going to do as a business person? Well, one thing would be to demonise the opposition, as has always happened in markets everywhere, anytime. Sometimes the demonisation might be warranted. Microsoft Windows PCs are far more prone to viruses. Get an Apple Mac. Apple Macs are far more expensive and less customisable. Get a Windows machine and be really in control of your operating system and apps. Do you like games? Avoid the Mac. Get a PC. Do you like creating? Get a Mac. Avoid the PC. But here, the consumer makes the choice. Our competitors' clothes detergent can leave your shirts dull and lifeless. Buy Breeze washing detergent for bright, fragrant clothes after every wash. Make the smart decision. But here with energy production, a complicated area. With as many unknowns as knowns, the individual is told there can no longer be a choice. Or if there is, it's a choice between the survival of the planet and death and destruction. Climate change is an emergency. Every flood, fire, heatwave, each drought and supply chain issue and cold snap, each time crops fail or a species is reported endangered, that's all climate change. So you can have all of that, the death, the destruction, the decay and the disease, or you can choose life and renewables. If one did not know better, it would not seem to be science speaking to you here, but rather a marketing campaign of a kind. A choice is being offered of a better detergent, or rather better electricity for keeping the lights on and the heating running. The healthier choice, the more moral and virtuous, wise and indeed scientific choice. Who could possibly choose otherwise but an ignoramus who has been blinded by scientific illiteracy and a moustache-twirling nefarious concern for profits above people? Never mind how much money there might be in renewable technologies. Never mind how truly renewable the technology is, given that all those solar panels, wind farms and especially batteries need to be replaced and manufactured over and again. Ignore the fact your own mobile needs to be replaced every couple of years once the battery goes for good. These things too can be solved for much larger batteries that will be relied upon almost solely to power the grid on cold, still winter's nights. At least we will be off coal. Here in Australia over the last week, the news has been wall to wall about how the eastern states of New South Wales, Victoria and Queensland, but especially where I live in New South Wales, have been at risk of blackouts in the major cities. Now, Australia, it should be known, has some of the largest coal, gas and uranium reserves on the planet. We contribute something like 1.16% of global carbon dioxide emissions. How can a nation so rich in natural resources, specifically the natural resources used for producing electricity, be in a position that countries with almost no natural resources of the same kind, one I know about is South Korea, are in? South Korea tends not to experience blackouts or even the risk of blackouts. But we just have been told that we're at risk of blackouts. In terms of coal, Australia is third in the world with 14% of all coal on the planet. While South Korea, it's ranked 46th in terms of coal deposits. It's got less than 0.1% of all coal on the planet. And yet, electricity in South Korea, where most of the resources for producing it are imported, is far, far cheaper. Astonishingly, given those statistics, the sheer amount of resources literally under our feet in Australia, extracted as it is and then exported, the cost of electricity in Australia is around about 0.216 US dollars per kilowatt hour, 21.6 cents US cents per kilowatt hour. That makes us 26th most expensive on a list of 147 nations. Now, more expensive than us, admittedly, is the United Kingdom. They're 8th at 0.265 US dollars per kilowatt hour. But that makes sense. They're not sitting on huge coal deposits, although they have some, and they've shut down, I think, some of their coal mines. Germany is even higher, even more expensive, 4th at 33 US cents, 0.33 US dollars per kilowatt hour. But the USA? Well, they're all the way down at 56th, only 0.159 US dollars per kilowatt hour. South Korea, who imports almost all of its energy from outside, are 90th. Their electricity is only 0.097 US dollars an hour. China, cheaper still, 101st on that list, 0.083 US dollars per kilowatt hour. And they're importing much of their coal that they burn to generate their electricity from Australia. So even with all the transport costs, they have to get the stuff all the way from Australia to China, they still pay far less than we do in Australia. And when I last checked, and I looked it up, Beijing was not at huge risk of continual blackouts. Not that we are either, but the fact that it's even on the cards is bizarre. It is policy and not resources that makes the difference. Knowledge here, choosing what to do, makes the difference here. And the policy that we have, policies where blackouts become a risk, where resources are in complete abundance that would solve the problem, is bad policy. By the measure, it's creating worse problems than it's solving. If the best we can do is mitigate 1.16% of global emissions, even if we stopped burning all of our coal here, and yet remain in an electricity production situation as precarious as some barely industrialized nations, something has gone terribly wrong. And it is not a lack of investment in renewables. It is a shift far too quickly from reliable, cheap and efficient coal, which is beneath our feet and which could make us more wealthy, to technologies that are unreliable, most especially in winter. And yet people continue to vote for those policies because they're being told again and again it is the scientific, virtuous and good thing to do to save the planet.